definition, recall that a function f is odd if for all t f of minus t equal to minus ft. So example, ft equal to t, this function is odd. Ft equal to t, this function is odd. You can prove it by definition. F minus t is minus t, which is minus of ft for all values t. So this function is odd. So we have the first definition for odd function. And let's do another example. Sine of t is also odd. Example 2. Ft equal to sine of t. This is odd. So for all t, f of minus t is sine of minus t. Sine of minus t is minus sine of t. Minus sine of t is minus f of t. So you see that for all value of t, f of minus t is minus f of t. So this function is odd. Second example. Let's do even function. Definition of even function. F is even if for all t you have f minus t equal to ft. Example, ft equal to t squared. This function is even. So f of minus t equal to minus t squared. Minus t squared is t squared. T squared is f of t. So you see that is indeed even function. Here another example. F of t is cosine of t. So this one is also even. F of minus t is cosine of minus t. Cosine of minus t is cosine of t, which is ft. So we have definition of odd and even function. Some properties we should know. Properties. So if we have two even functions, saying I take the products f and g, they are both even. This means that ft equal to f of minus t, gt equal to g of minus t by definition for all t. You can do the multiplication. Take the products of two functions. You have f times g. F times g at t. This is ft at f of t times g at t. But this one is f of minus t, g of minus t. I just use the properties here. This one equal to this one. gt equal to g minus t. And this is f of f and g, f times g of minus t. So you see that the product f times g is also even. F and g are even, implies f times g is even. And similarly, you can do it for odd function. Now if I have f, if f and g are odd function, and you do the product, f times g is even. And the last one, if f, g, one function is odd, one function is even. Let's say f is odd, g is even. Then f times g is odd. Let me show the last one here. F is odd, f minus t equal to minus ft. G minus t equal to gt. you do multiplication f g at minus t. So this is how we do multiplication, f minus t, g minus t. But f minus t equal to minus ft. That is for the first one. For the second one, g minus t equal to gt. So this is minus fg at t. Yeah, so you see that function f times g is odd. Yeah, so there's three properties we have, the products of two functions. So another properties you should know is the integral. So let's draw the graph of odd function. So for example, if I have this graph of function f, so it's look like this. Yeah. So y equal to f of t, this graph, and because x or t here, t f of t, this point has a coordinate t comma f of t, because f is even, so you know that minus t f of t equal to f of minus t by definition of even function. So minus t comma f of t is also on the graph of the even function. So minus t f minus t is the same as minus t f of t. So the graph of f is actually just, I do the reflection here about the y-axis. So this is the graph of f, and the integral ft, for example, over integral of ft dt over a symmetric interval minus a to a. For example, minus a is here, a here. This integral is the area under the curve for x, for t between minus a and a. So this area. So you can do it as 2 times the area under the curve from 0 to a, ft dt. So I hope you understand that the integral is actually the area under the curve. The integral area between minus a and a, you can do it twice, area between 0 and a. Similarly, I do the same for odd function. Say we have the graph. Say we have first half is like this. Let me draw it like this. So this point saying t comma ft has a coordinate t comma ft, because the function is odd. So for minus t, f minus t is minus ft. So the point minus t, f minus t is the point minus t minus ft. So coordinates of that, say t is here, minus t is here, minus t f of t, this one is f of t. F of t is this long, minus f of t should be here, minus f of t is here. So this point right here is a point of coordinates minus t, f of minus t, or minus f of t, minus f of t. This is also a point on the graph. So actually the graph of f is, so it's look like this. And I bring it somewhere here. Yeah. So this curve so we have the graph, the red one here is the graph of function f. The graph of f of an odd function is symmetric with respect to the origin. So now I can compute the area under this curve if I do integral, say from minus a to a, ft dt. F is odd. Then this one, say minus a here, minus a. The area, you have this interval, the area under the curve, this area plus this area actually equal to minus this area. They cover the same area, only the difference is the sign, one above, one below the x-axis or the t-axis. So this one is minus this one, so this is 0. So this is also a nice properties we should know. If f is odd, the integral here is 0. If f is even, the integral is twice. So now we are ready to compute the Fourier series of odd and even functions.